So what I want to do is unpack yesterday a little bit more.
Yeah.
So I was talking about quite some subjects.
Mm-hmm.
Anywho, so we got the Earth, yes, and at the moment we got to make whether we can build, whether we can grow. There's a lot of things that hit into that segment, and plus we've got a problem on the planet of gases, yes.
Mm-hmm.
Now hydrogen. Rocket fuel, yes, can make a lot of power stations if utilized in the correct way. However, it will still deplete oxygen into carbon. So you make hydrocarbons from, well, the hydrogen will go off to do what it needs to do, but the carbon. But this is very beneficial because it works with nature.
Yeah.
And nature works in reverse to this, and plankton and other things, but even still. So around the earth, around the world, we've all got different foods everywhere. Even from Africa, and the Hamali tribes have different types of seed that they have learned over the millennia of being around to crush all of this, and you can make certain types of bread and different things like that. All food is essential from any nation. Plus, we got the thing where we're in a sort of situation where everything seems to be corporized, doesn't it? Corporation, and so much more. And sometimes you might argue whether that's a good thing or a bad thing. I would say it's a bad thing for futures of governments. I would say that could be quite a bad thing for govs. However, the Industrial Revolution. Royal family was in the Industrial Revolution, and the rest of the world. I'm believing that all of the nations that grew and are established now were some way related into the Industrial Revolution. So there's a lot of bloodline knowledge in this, or there is government knowledge in this. They've passed all of this information down, and they've kept it. However, we start talking about going green and going this and going that. Okay, which focusing on that is an issue for long term, right? So there are a lot of issues that seem to be about. So yes, it's nice to have shops and small shops and different things like that, where not many people are making an absolute fortune, but they are living comfortable. More comfortable than they need to be, yes?
Yeah.
And that's a nice thing. But then we go over to corporations, and it's billionaires holding on to money, holding on to more money, which then puts more pressure on a gov, more pressure on society, more pressure on people, more pressure on small businesses. And then morale. Morale is the thing. But if we focus only on green, we got to wake up to that. That is definitely an issue, right? If we tip the balance of the gases in one direction or the other, that is a situation. And then going green, .govs, different things like that. So everyone's looking for their place, and space seems to be the place where everyone feels that they're going to lose their structures and everything else, yes? Which is not true. It actually builds a lot more. But you've got to look towards space in order to make all of the... it will all line together. It comes into an alignment. So we've got to look at the gases. That's a realistic one. So gases, yes, absolutely. And we could say petroleum and different things like that have a knock-on effect, which then make monoxide. I'm unsure and I'm unaware. I think it's because the rocket burns the fuel. So we'd have to understand that the oxygen is not coming from the atmosphere. Car engines seem to take it from the atmosphere. Combustion engine. You saw those cars that they all started backing up the road, yes, for the works that are being done here. And you could smell, if you'd be aware of it, the intensity of the fumes towards the last car. They're all sitting there with their engines running. One engine sucks in oxygen, bits of carbon, bits of anything else, and then throws it out. You look at that as a river in reverse. At this start of the river, being the engine at the front, is more purer than the engine at the back exhaust fumes, because now it's sucking in more and more carbon each time it goes through. This in a combustion engine, I think, creates the monoxide, because there are certain things that are bashing together. And the more and more and more you reach up in a gas with carbon, I think these are going to start to react because you've changed the ingredients. Anywho, so we have to look at that as realistically long-term. Is it feasible? Not really. Can plants absorb carbon monoxide? No. So you'd have to look at that again as it causes a lot of problem to life. Now, what we could do, it's expensive, is start sucking in this gas. But you'd have to leave it until there was a time to be able to defuse it, deseparate it, and everything else. Lightning seems to fuse things, and it also pulls things together. If you made it in a liquid and then put it into a lightning chamber, would it separate it a bit like it does? And if it goes too far, a bit with the water, so we take H2O, it separates hydrogen and oxygen.
Yeah.
But if you leave it long enough until it's gone through all of that process, it then begins to bind oxygen together, which then creates ozone. So, yeah, fine art. But if you liquidize these gases, you might be able to separate them. And then what you do with it after that, that's one way of doing it. Or you look at the situation and think, how can we maneuver this problem into a long-term solution, which is easy to get there, and which one has the most benefits to society and the world over? Because anyone that walks through with that is the champion. But it's going to take everybody becomes the champion together in that structure, and then it's all people working together. Then you're all the champion, which is a great way to be. It's good for society. No adverts. Anyway, so we have to then look at plants and different things like that. Now, we've got the orbit. I did this yesterday in quite a weird way, but even still, we could make a very big orbit, yes? And we're just going to draw the sun here for a second. Now, on Earth, we have to wait for a planet to tip this way, summer.
Yeah.
And then this way, summer, summer, summer. There's always a summer, there's always a winter, yes?
Yeah.
And there's always a bit in the middle. Out in space, there is none of that. It's summer based on where you orbit and how you orbit. So we could do this very slowly, and this part from here to here becomes spring, summer, autumn. This bit becomes the winter. Yeah. That's a very slow orbit. That's very, very slow. Or you speed up the orbit and all of these things become summer. Now, if we take these as being modules, by the way, of farming, space farms, and built in a very beautiful way that utilizes the light that comes in, and if they have to rotate shade and light as they rotate this way, they're also rotating around the planet. Nice, very interesting. If each nation were to find out their different versions of food, this is why it's important to build space farms and to go that way. And if it were to be gov, you must hold on to this stuff and never let it go, ever. It's yours, keep it, hold it, and then people that come together will build upon it. And then it keeps, I don't know, whatever you want to call it, these different. If each nation, each one, and how much room is there? Well, there's enough for every single nation. Now, of course, this can cause problems. Perhaps this might cause problems, but it doesn't have to be the Earth it orbits around. It could even be Venus. Yeah. It's still going to work just as well. So just in case it starts blocking out some of the intensity of the sun, which then might make you complacent later on because it doesn't feel as hot. Perhaps that's going to change the weather. We'll just take it as a blueprint for now, and even if there are certain ones, if each nation, so we could take Russia, America, Britain, EU nations of all your different variants of food, and you were to build all of these space farms, put these in, you're then getting food. Not only that, you can then start to switch your gases. So you could then make, some of the carbon into oxygen. And again, there's going to be an abundance of hydrogen in there as well, perhaps. And you start switching these gases out. If you are creating from hydrogen, and this would be hydrocarbon then, you're going to be making a whole.
Whole? What is a whole?
Hydrogen and oxygen. Might as well, yeah, because you're going to be switching the gases out, right? So these are going to switch from one to the other. Yeah. So I'm pretty sure it's nature knows what to do with this. And it also, a little bit, knows what it's doing with this. However, if you were to take this and put it into a rocket, do you see how it can then begin to... You can then begin to bring the food in, lift up the next load, bring down another load, and this is a self-fulfilling prophecy in itself, its own right. Yeah. If you're adding in plankton, what else is it? It's not just plankton, is it? It's another one that sits on the ocean.
Plankton are the small animals, so that's...
These create oxygen too, don't they?
Yeah, you have the green stuff. It's not algae. Oh, I forgot the name.
Yeah, anyway, either or, if you were to put these in between this as well, Because again, they seem to grow when it's summer. So we ought to look at the things, and we've got to remember something as well, that if this goes on to feed whales too much, whales will overpopulate, overeat this plankton, and therefore can then start to really impact how much oxygen you have on the planet. Now, you could say you could go and get rid of all the whales, but no, whales would then need to be kept in a certain niche, not to be too many and not to be too few. It's an interesting phenomenon, isn't it? But life, when it starts to expand, and you think about it, how many stars in the universe?
Yeah.
Well, there's less grains of sand on your beaches. And I think how many humans there are compared to stars. And that's only what we understand so far. Move further and see more. But there again, become blinded slightly behind. The more you move out, the less you see of what you once know. And then it's based on memory. Very interesting. But if this was to be orbiting around these areas, I mean, even around Mars is possible, I guess, could amplify it, because we've got to understand that lenses, lasers, magnifying glasses can help in this situation too. Anyway, but even still, keeping this with being in orbit around, that's a lot of food. That's a hell of an amount of food. And what's more, how do you bring it back into the planet where you can make it corkscrew? If each nation were to do this, each nation were to join an alliance, let's say, you're independently different. You know, united on your differences. And then you all get food. Every nation gets food in this. And then it depends on how fast this moves around. Because then, if you have this side as the preparation phase, you know, where you prep, and this side is sort of like the, I don't know, I could call this one the active stage. From here to here is the active stage, which is going to grow your food. This side is then going to need to be the preparation stage, and eventually you want to be able to move up to move this to get quicker with the prep, so that you have more action, which therefore is more food, and then you begin to really start to exchange the gases. Because once you bring the payload back down, imagine if you were to do it that way, who knows? Around Mars this would be different, because you could get it from Mars itself, because it's CO2 anyway, isn't it? Yeah, hydrogen and carbon, isn't there? It's a dominant gas is hydrogen, isn't it? Among other things, but even still, this whole process around Mars can also feed anything that's on Mars, so forth, so on. This begins to expand life, and it also is converting the gases, which is most important. Therefore, when you start getting into the negative, so at the moment, what we say, carbon, we can say CO2 and O2, the balance tips around winter that CO2 becomes maxed out. And this one doesn't really max out in the summer. Oxygen doesn't really max out in the summer. It just peaks. And the International Space Station is around 87% oxygen, isn't it? Saturated, give or take. I think that's a high level. So astronauts are already collecting data by being in a high oxygen environment, and they seem to be doing all right. Actually, there seems to be much more. So we can understand that there's a threshold of what humans can take, and if it is at that level, what's the long-term effects of that? Because if you begin to make the planet so that it begins to, rather than peak, you reach the peak in winter as opposed to reaching the max of CO2 in the winter, yes? You want to be able to reach the peak in the winter of what you get in the summer. And summer wants to be reaching a max of oxygen. Why? Because this means then that you could make hydrogen into powering turbines, and it's going to release hydrocarbon, which then can go into the system. And then there's this careful expansion of nature versus power. Power is something that people need, yes? And maybe you don't need that much, but even still. And then there's an expansion of food. So therefore, with the expansion of food, if you're not making power, you've also got growth. No idea. Anyway, but still, you then got power, electricity. You then got growth. Growth in what? Species. Why? Because there's more air. There's more air to exchange. So the more you expand nature, the more it sings benefits to you. And plus, with the invention of the hydrogen rocket, this already starts to get you into a self-fulfilling prophecy, is what it does. That already makes interstellar space travel feasible based on this many. And then when you begin to collect other gases from Mars, you could terraform Mars, but the problem is with it, it's kind of risky. It's very risky. All it takes is some event to happen and change all of those gases. At the wrong time, just before you plan to go, that can be disaster, because you'll look at it as a bank. We've got all of this here. If we suck this out here and do it, you see I don't know. When you're on a planet, you sit as a target.
Yeah.
Because the planet wants to bring things in. It's still creating. It wants to be a star. Overall, it wants to be a star. Sure, it's temporary platform for life forms to rise up on, but overall, it wants to be a star. Mm-hmm. And what do planets do? They bring a lot of stuff in. And whether that is noticeable, so we have the meteorites that burn up in the atmosphere bit by bit, and we all think, oh, that's very nice. It's nice and it's not. It's still expanding and puffing you up slowly, very slowly over time. Mm-hmm. Until before you know it, you're reaching the size of Jupiter, and then things become nigh on impossible to reach space after that, pretty much. And this can change the life forms because of the different ingredients that come in. Who knows what it's bringing in? Who knows where it's coming from? But the one thing that's a bit concerning for me personally, as I look at this, is the methane. Something knocked Uranus on its back. Mm-hmm. I believe some of those shards, because when we look at Saturn and all of those rings, they're very fine powder. Yes, some of the geysers from the moons have fed into that, but a lot of it is very dusty. And there's a lot of dusty around Jupiter, and what is it made of? And if something smacked Uranus on its back hard, there would have been a lot of fragments fly out. And if they are they full of methane? Just takes a few of these to, it'd be frozen down for sure. It's almost like the yin and yang. Get closer to the star, this might start venting off a comet trail. But if it's frozen and the light doesn't hit it and it reaches the shadowy parts of the planets, orbiting around those, it's going to seed the planet. Mm-hmm. Now, what does that methane look like on a planet? And again, if it burns off bit by bit, it just seems like it's insignificant. If that is leaking a lot of methane, where's it going to go? And then how does that affect climate? So meteorite affects climate, stars affect climate, planet alignment affects climate, CMEs affect climate, internal core affects climate, gases affect climate, and exchanges and not having enough balance. So anyway, planets at the end of the day want to be a star. That's what they started out as being. And their fundamental baseline ingredients, I like to look at this as a massive pieces of dough, and you sprinkle around in circles around it. You got your center star, yes, in the nebula, and then you've got a certain amount of gas versus particles and debris, and in the planets start coming and clobbing together, let's say, in different areas. They sort of maneuver, pulsate in and out as well as up and down. And with this, some of these particles get flung out. That's why we find trace elements on certain places and more abundant baseline elements on different planets because of this mixing and churning. It's chaotic as anything, and it's pushing all of these particles. Some are being thrown in and brought into the Earth, which then moves stuff from the outer reaches of the nebula and it brings it in. Trace amounts, but its abundant amount is going to be in the part where it begins to condense the most. Yep. This particular bit is going to gobble up all of that flour there, and if you put a piece of wood over this area and do it with different spices, yes, it just loads of circles of spices. It doesn't have to be a circle, but still the predictable orbit of Earth. And then there's two types of orbit, isn't there? There's the one that is elongated and the one that's a bit more rounded. Again, these things can be utilized. Yeah. So for growing food, generating power, generating growth, protecting against extinction, because again, that's going to be something. That's something. By that time, if this is the way it sort of goes, because at the moment it's we could say industrial. Yeah. You could use the star to forge a lot of things, magnifying glasses, anything like that. You can really charge up the star without getting too close to it. And eventually you'll get closer to the star to be able to forge closer to it, lay things on a planet and use the planet as a, building a massive steam train out of metals and different things like that. I mean, that's impressive, as to say the least, right?
Mm-hmm.
What could you do with a planet that orbits close to the sun with that? You can then begin to imagine that you can make colossal vats out of metal. Well, find the metal first, yes, sure. Jupiter's got a lot of it. I mean, being able to get at that, interesting. Bigger the planet, maybe it's got smaller metal. Who knows?
Yeah.
Maybe the smaller ones have bigger metal, and this, and you got it on Mars as well. So humans, that's a lot. And if you think about it, would that cover a moon? Do you think if you were to spread that out nice and evenly, could you get that to cover a moon? My word, it would ring like a bell. And then there's sand. Sand is abundant. Sand always gets looked at as something that is insignificant. But actually, what is it that makes you feel good at the beach? Is it the beach? Is it the ocean? Or is it the sand? The sand, the antenna frequency, Anyway, you got metal. People have a lot of allergies to metal. Most life forms react very negative to metal.
Yeah.
But if you line it with glass, thick glass on its own is not going to be protected enough. But again, inside there, you line it with glass. It's no different from taking a cardboard box and lining it with a bit of plastic and look at the liquids you can store in it. And then look at the pressure it can take. And then if you build a vacuum in it and different things like that. And anyway, so it becomes an industrial age, to be honest. And even then, if the metal can withstand it, and you can use the metal in two ways. Imagine coating the moon in metal, putting it closer to the star, maybe aiming a load of magnifying lenses to it just to amplify the heat. You can scorch through rock with this. It's risky because, when are humans ready to be trusted with a next generation of tools? That's the question.
Yeah.
It's one thing being taught how to make things that can slice through planets. It's another thing doing it, because you'll test it on something too close. And then it becomes too long process to reach something that's further away. So you can always do this where you shrink it down. Can you imagine that, cutting out landmass on a body in order to get deeper into it? That's a very interesting thing. And then you would flick up the shard that you've done and make it go in orbit around the body. And then you can also use these shards as shaders in order to shade down the intensity. Or in some cases, you need to maximize the heat because it might be too cold. But there again, and then if you want to break the metal, there's two ways to do it. It's freeze it, flick it, and then you break off the shards this way. Again, space is very cold, but you've got to be able to make it colder. That's interesting. Or you heat it up till it goes molten and then whoosh, knock it off in teardrops, so to speak. Very large teardrops. But yeah, it makes it a bit more manageable. But again, it's going to be heavy to lift this stuff up. So you need smaller bodies to be able to do it. Or you need to get really whizzy with it. But again, opening up all of the shit that you don't need and exposing a hard chunk of core. I mean, again, this gets you there further, and then you orbit this closer to the star, melt it. Anyway, if you were to make that into a vat, let's say, can you imagine that? It's a bit like the industrial age, and that's where it works, because you've been teaching without realizing it, that the Industrial Revolution has been teaching you a lot. You just don't realize it. And yes, this climate and everything else, it's so tragic, and it is, it really is. But again, gotta think smart, not think hard.
Yeah.
Hard thoughts will, gotta think smart. What is this teaching us? One, right, it's teaching us that we do need power. Can we lower power consumption? Well, the answer is yes. Once you start to build all of these things and you're getting up into space and you've got flask kettles, you've got flask water tanks, that becomes socialism. There's no point everyone having individual tanks. You might as well have one core water tank. I wouldn't do it that way. I would break it up. But even still, to heat it, it would be one central sun that heats all of that, and everybody benefits from it. Again, this stuff should be so, 1900s, where it used to be paid for, and now it becomes a resource that's That's given. Why? Because it's beneficial that if you are here exchanging the gases, and the more life you have, the more nature expands, and therefore, you were going to say something. Go on.
No, I was just saying always have backup, not just
Yeah,
one.
well, of course, in space, everything must be in a backup, but you're less likely to attract harder meteorites.
Yeah.
It's going to pose more because the mass of the planet, and there again, it's not just about mass, right? That's one side of it, which is the E equals M
C squared.
It's MC2, yes?
Yeah.
And that's I agree with this and totally, but there's another formula on top of this, and I just don't quite know how to put it into mathematical equation. But there's also reach, and reach is atmosphere. So yes, as myself, things will come and collect onto me. But anything that's in my grab, which is my atmosphere, is mine too. And therefore I can really utilize the pull ratio of that. So the more expansive I am in atmosphere, I am making artificial mass because I can now grab more. And technically, if I can't grab more, it's still going to burn up to make me bigger in order to grab that object next time. Because it's going to be puffing up my atmosphere, and therefore my reach is further. It's like maneuvering a star. Think of that in colossal distances just traveled. And to you, looking at the star wouldn't be very much, right? But to everything else that's smaller, the gravitational pull is massive. I don't know how it works for stars. Perhaps it's more a magnetic field. And is a magnetic field another way of reach, which is more reach than the atmosphere? If you think about it, a magnetic field.
Yeah.
Again, it's a reach, and it depends on what charge is in the comet. Or what hemisphere did it blow up from? If we're talking about a star, did it come from the north, the south, the equator? Is it a bit of both? If it's a planet, same dip, did it have a magnetic field? If it did, what was it charged at? Interesting, because maybe it's subtle to us, but to a planet and a magnetic field, I want you, or I don't want you.
Oh yeah, you see it when you have a shard of metal that was charged and you put it just in the right distance from magnet. It's like moving this way, that way, and then it prefers one side and pulls to the end of it, to the charge.
So you would think about it as magnets, north and south, and then we think about a stationary north and south. A north and south, and if this one is more charged north, still got some south remnants in it, don't get me wrong. But it bit by bit, it's going to pull it, especially if it gets in the magnetic field. Plus, our star has a magnetic field as well. So clearly, it must be I want something or I don't want something. What will put me out? What it wanted in the beginning might not be what it wanted later on. And does it have an option to maneuver this magnetic field in order to push things away and bring things in? That's another thing. And then are the planets are alignment in this, because the star dominant force is like, you're staying here. My magnetic field is bigger. Jupiter has an incredible magnetic field, but still. It's probably just an amplifier. It probably boosts our star's magnetic field. Now, I reckon the reach is further in that. Magnetism is a funny thing, because isn't it lots of, if you have one magnet, it's impressive. Now put them all the same facing way. And now make a grid of them and put a bit more of an intense one in it. It seems to boost the field. So again, with the star, it probably magnetic fields are a bit more. So neutrino, you could then ask a question, are there more planets with magnetic fields? Yes. Does this one generate its magnetic field? Yes. Is there also this friction? We understand that when we look at Jupiter. Jupiter's 3 billion amps, something like that, million maybe, I don't know. Don't really remember, it doesn't matter. And it's Jupiter's little moon Io, right, is causing that discharge on Jupiter at a constant ratio. And also Jupiter is causing some interference with Io as well. And we see that process. Now, what happens if you add another one here, same speed, and another one here? We'd have to imagine that there's a piece of metal that runs from all the way around, a ring that runs from Io one side, and it runs all the way around Jupiter and then back into the other side of Io, a ring, metal ring, which is the gravitational field, if you want to understand that. So probably wouldn't work with metal. So we'd have to imagine something elastic that can stretch and squeeze.
Yeah.
So the differentials of up and down, it still has that movement, that slight movement. So we couldn't use metal because it's too rigid. And if we were to put multiple ions around Jupiter, what do you reckon would happen? If it is discharging 3 million amps, for argument's sake, from one, and you are able, in a ring, to get them all at the same position that Io is, and each one is now going to add in another 3 billion amps, another 3 billion, and another 3 billion, and another 3 billion. What's the first thing do you reckon would happen on Jupiter? That energy is not going nowhere. You can also build spacecraft this way.
Yeah.
Yeah, and also if you were to live around Jupiter, you know it's got longevity that is going to be more than the Earth. You wouldn't live on Jupiter, you would live around Jupiter and perhaps closer to Io. But again, it comes at a colossal risk because how many meteorites will smack into Jupiter because of its reach? And you're going to aggravate something else. I think the magnetic field will increase.
Yeah.
And then Jupiter's on its way to becoming a neutrino. It's sure as shit, not before long. That is going to have an impact because that energy is going to mix those gases in a way. We understand what lightning does here, especially with oxygen. It's not just oxygen that it does it with, and nitrogen nitrate, different things like that. So again, you can understand that that is going to be doing something to those gases. And then the interior heat, that energy, what's it going to look like? The planet, if it gets too much, it's got to release it somehow. And then it makes Jupiter's reach even more so, but it also amplifies the star. So the star's heliopause will probably move. I think it'll extend more. So that's more energy, that's friction. Friction generates more of something. It's interesting, isn't it, really? You think it'd destroy it. But that's your one particular. And the thing is with Jupiter, which again, I would experiment with this sort of stuff. That's the thing. Like, if you can go very futuristic, I'm already playing with this sort of stuff. I haven't got one Io ring around of many Ios. No. I've turned the whole thing like star light coming out. You know how everyone depicts stars, yes?
Yeah.
We've got to understand it as three-dimensional, yes? Yeah. There's a ring system all the way around it. In multiple different ways. Oh man, and trying to make it so it's timing, there got to be little gaps in between it so that each one moves, it doesn't knock into the other, and you don't have rings attached to them. Yeah, I just keep amplifying it and amplifying it, and then there was the other way of doing it this way, where there's loads around here, and then there's the next bit like this, and the next bit like this. The only thing is, it looks like a pyramid. It's interesting because it has to get smaller because as the planet goes to curve. The Ios become smaller. So it looks like a diamond. In a way I can explain it. The equator, and then
And they rotate as well?
Yeah, they're rotating all the way around, all in this dimension, but all the way up. So from a perspective, it looks like a diamond, which is quite interesting. Does it make diamonds? Anyway, but even still, and then it's trying to calculate how much, which I'm not using mathematics, I'm just using what's already there and then amplifying it. So if that's creating this, could it double that? Could it triple that? So, yeah. But this alignment is then what allows all nations to get food. No one fights over it. So everyone has a summer. It would be great if it was done, again, you can do this over a course of 24 hours. And then you're all getting a summer at the same time. By one's coming down, the others is going up. You're also taking care of gases naturally. It's industrial because it gets you next to the Industrial Revolution. You have been taught so well with this already. You've done really well with it. In fact, to build the Industrial Revolution, it's got a very bad rap. But has it got a bad reputation? Because of how powerful it is. If you were to align this and use the Industrial Revolution going backwards towards leaving the planet as opposed towards corporate, where would humanity be already? I mean, that's a question. Anyway, you've got to sit down and have this question with one another, because this could get really going on very quickly. And you'll be so focused on it that you'll then see value in each other and your differences, but it will be united on those differences. Yeah, it's still a cunt. That's fucking better, my friend. Whatever it may be, it still keeps the pot going. No one's asking you to come fall in love with each other. We ain't got to all act the same way. You do certain things there, that's fine. We do certain things here, that's also fine. You do certain things over there, cool, wonderful. But what it does do is it safeguards all the people that look up to you in that way. And again, I think it starts to put a smile on people's faces again. And then there's more room to expand. There's more to eat as well, because then food becomes the biggest thing to trade, doesn't it? Then this begins to start supporting houses. That then, if these gases can be switched out on a planet and recycled into, I don't know, hydrogen that hits a paddle that then begins to turn turbines. Either or, there's a mechanism from it, either or. And this goes back into feeding the very thing that you eat. It's amazing, really, isn't it? Rocket fuel, star power. Yeah, it's beautiful. Yes, okay, these things are not great if they go wrong, but neither's petrol stations. Neither is making manure. That stuff is so volatile anyway, so neither is the sun. Neither is sitting on the planet. Okay, perhaps it won't be great in a car unless you can convert it in the moment, and as soon as there's any sensor breaks, it shuts it down, and it's just water. That's the thing, isn't it?
Yeah.
So yeah, it doesn't have to be a hydrogen fuel that goes into the car. It's a hydrogen converter from the water, if that is even possible. And then there you are. It will only create the initial bush. And by then, it's only going to be able to give enough to go into a combustion engine anyway. So it will be combust. But again, I think that might start making a similar problem that you've already got. So it'd probably be easier to charge up electric cars in that aspect. And electric cars are pretty good only because they represent remote control cars. I upscaling a remote control car, yes, and I was putting it through all of its paces. Backstory is that if you put that into a planet and you're from the distance, could you imagine that? Being NASA, orbiting around the moon every now and then, and a figure of 8 coming back to the Earth just to make sure everything's okay. They get better and better at it. But each time they go around the moon, they got these little remote control cars that are already down there that they can operate whilst on the International Space Station. How fucking awesome would that be? I would love to do that. Or remote control robot. One's got the digger today. The other one's got the scooper. One's got the symbolic human. I don't know. And it's what's its outfit? Every flag on the planet. Yeah, and it is symbolic for that's where all nations should expand towards if you want to. I just don't see why you wouldn't. I mean, to go this way that we're at now, meh. Look at what it's doing. We got to be honest with that. That seems to be quite the red flag. And also, we want to spoon drip everything and do this, and this. It makes sense, but it's also causing the problems later on. When you fast forward, it causes more problems. Whereas really, this is already stuff you know very well. You must have it. The records are there. It happened once, and it can happen again. And then before you know it, the Industrial Revolution, but a better way of doing it. That was the first trialing, the trial and error. What worked, what didn't? What did we learn from it? All of this stuff. Okay, aligned to it, understood. Okay, we can move again. All right, we can eliminate that one. All right, we can eliminate that one. And then it's bit by bit then, isn't it? And then it's, before you know it, what else can we eliminate? Well, then you shift it over, planets, this. Technology will become something that you need. You know, if we spoon drip internet, each time we're going to upgrade it. Okay, the infrastructure here, I understand that. But if we built something that had faster... speed of light, you know, there's a file there, and you press a button, blink, and it's already there. It's like 100 gigs, and it's just, zoom. Okay, then. Yeah, that's the sort of, once you reach that, people will get bored of it, don't get me wrong, but I don't see how they will. But what they'll do is they'll then begin to reach out for something else. If we spoon drip it, it takes longer to reach the goal, right? So if you've got like the next X amount of years to reach this moment here, if you already brought it up to this moment here, people start reaching for the moment that's up here. And then the Holy Grail is certainly up here to get around the speed of light. At the moment, we limit ourselves to believe the speed of light is the fastest thing. And that is conditioning, self-conditioning. We are conditioning ourselves to believe that the speed of light is the only thing and there is nothing faster. That means there's no point trying. Already know the answer. Got it. Gone. Yeah, in terms of light, that perhaps that is true. But what happens if there's something that you can operate with that is outside of that structure? the speed of signal. So we could call it the religious signal. You want to call it the God signal. You want to call it whatever you want. What about operating at that speed? Which then formulates into clone. The speed of clone. The speed of master and slave.
Yeah.
What's that speed look like? Which then gets you onto twins, identical ones where the egg splits apart. And then the gaps fill in. The gaps fill in. Could you imagine taking an atom, splicing it off, and it expands, and you find a way to expand it as the same size? How many times can you splice that? And then off of that one piece, how many splices do you have? And if each one acts like master, I send message, the slaves receive, and then if someone wants to write back, the one that was once master switches over to slave, and these ones, one of them becomes master, which then sends, everyone has to wait their turn in that. That's the only thing that's a pain in the ass. But again, it gives you the time to think about your response.
Yeah, you can do it like when you have walkie-talkie or something like that.
Yeah.
Or you talk, and then you say over. And then the other side is talking, and then they say over. So,
did you ever sit around the group when you were younger and someone would pass you a particular, whatever it may be, anytime that one of these children hold the pen, you get to speak, everybody else must listen?
Yeah.
Do you ever hear that?
Yeah.
Do you ever get that taught?
I didn't do that, but I have seen that.
You've seen it?
Yeah, on TV.
What do you think that is?
That's good. Because
what do you think that actually is?
You can pay attention and everyone gets to say something.
It's one of those remnants that have never gone away. But yet to you, it seems like everything nowadays, with the invention of the mobile phone, that becomes less significant. But actually, it has the biggest significance because it's the next step above all of this. At the moment, we take it for granted. We write a message, fire. Response, fire. You can get a response and be firing at the same time. There's actually three types of way of talking. One is long-term, back and forth, which then requires thought and different things like that. The next one is instant, back and forth, which is a little bit more closer. And there's another one where you can fire 3 messages at once, and by the time someone's replying, you get into this overwhelms people. Did you know that? It also teaches them to say things that they wouldn't usually say. So sometimes I do get into that, I'll fire 3 messages, and by the time someone is answering one, I'm already answering that one, plus
someone misses answering.
It's jogging up the conversation to be able to hold that conversation. It was something that me and my sister used to practice quite a lot, was throwing out, but it used to be verbal back then as opposed to messaging. So, and then it was being able to answer so we understood that there was multiple ways to. Oh, it was crazy, but it was brilliant also, but it's very good learning. But it teaches you about atomic computers, atom computers. And again, twins are already the understanding of that. It's just the center atom, their center core. Interesting. And then how many times can you splice that? Because technically the brain, although we look at the all see and I, we think that that's just one. Doesn't look like it to me, it looks like 2. The Egyptians understood this, hence why you have to cut it open, right? And then you will reveal 2. Not 1. Depends where you hit that. That already looks like 2. And then that, if we were to talk on an atomic level, heavy ati, you've already, you've cut it in half. Aha. I think those are switched out. That's the only thing that separates twins. Anyway, I should really let this wind down. It's getting late. Right, okay. Yeah, I'm going to dive into this again, but later on.
We'll continue
that one. There's more
because
to
that's
pick from this.
interesting.
There's so much more coming. So, let's leave it there. Do well.